Okay, so today we're talking about ticket issuing systems, which is what we are, and specifically the SDCI Plus. So really to understand what SDCI Plus is, we kind of need to talk a little bit about how a ticket issuing system works, and then how the SDCI Plus fits into the fulfillment process. It's one of those areas that is sort of shrouded in mystery, but as we'll see, it's not really that complicated. So a TIS is a pretty business-oriented thing. It's a really domain-driven system. There's a lot of business logic in there and things like that. To be fair, it was approached from a business perspective. So as such, they kind of modeled it on something that everybody knew well, which was a train station. And to be fair, when they designed this all these systems, that's where the ticket issuing systems were. They were part of the train station. So as we go through this, I've sort of bolded and quoted a few keywords here that are core to the domain of what we're doing, but I'll describe a little bit that model of the train station. So every station has a national location code. You'll often see this referenced. It's an NLC. It crops up in a lot of places. And basically the idea is that in the morning people show up to work, they come to the train station, they go to their little window, they sort of sit down, they open their window in which they start a shift, their day shift has started, and then they start retailing some tickets through a printing machine. Now, as that machine is printing its tickets, on each ticket it puts a little transaction number. Right, so it is pretty simple. You come to work, you open your shift, you sell some tickets, you print them, and then you go home. Now, SDCI Plus is a file format, and it's used to describe the transactions that are made by a particular machine in a given shift. So these machines that are operated by people in the windows, they will issue tickets over the course of the shift, and the SDCI Plus is a record of all the tickets that that machine has printed, right? So why are we doing this, and why is it important? Well, basically, for every shift that every machine has, it will take its sort of SDCI Plus report and it will send it to a system called Lenin, which, if you really want to know, is latest earnings networked nationally overnight. There you go. And Lenin is responsible for apportioning the revenue from ticket sales to the TOCs that might be involved in that customer's journey, right? So if we have a £100 ticket sold from, let's say, Hastings to Edinburgh, it kind of might be divided up into sort of 4 or more parts. One train operating company, let's say Southeastern, might do the Hastings to London part, and they get, let's say, 30 quid, and then you go across London on the Underground, that's another £10 to them, and then you take a Virgin train all the way up to Edinburgh, and that's £55 for them, and then there might be a little bit left over for the retailer, or maybe not. And so that's what Lenin does. It looks at all the tickets that have been sold and allocates money. So naturally, this is why it's seen as such kind of a mission critical thing, and the main output from a TIS as far as the TOCs are concerned is this SDCI Plus, so that they can get their money accurately. Okay, so what's actually in an SDCI Plus file? Well, structurally they're pretty simple. There are actually a large number of record types, but to be honest, most of them aren't used, and I'm just going to cover the core scenarios. So in our case, we have a shift header, which effectively has the totals stored for tickets sold, and things like that, over the lifetime of the machine. That is followed by a version number record, which is the 2C record, and that has sort of installation date and these types of things. Then there are 0 or more transactions, and after that the last thing will be a shift footer, which is similar to the shift header but sort of updated with everything that's happened since the start of the shift. Now, I've said in there are 0 or more transactions inside of a shift. So what's inside a transaction? Well, a transaction is just a list of products and some payment records. Right, so each transaction and every product or payment record inside the transaction is given a transaction number, and when it's written to the file, they must be written in exactly sequential order. So there can be sort of no gaps or anything like that. It has to be exactly in order. And I've said that, you know, a transaction contains products and payment records. So you may be wondering, what's a product? In our system, the products are tickets, supplements and sundries. Now, tickets are basically just a right to travel. I'm sure there is a more complete definition of what a ticket is, but it's not necessarily something physical. As we know, there are barcode tickets, there are other things. It's just a right to travel, right? And if we say that a fare is the origin, destination, route, ticket type and restriction, then the result of that obviously has a price, but it also the ticket type has something called the validity type, which has a duration. So it might be a day, it might be 30 days, it might be a year if it's a season ticket. Now, the difference between a fare and a ticket in this case is that a ticket is really an instance of a fare that is bound to a particular date range. So if we have a fare, I think an SOR has a validity of 1 month, then that's fine. That's sort of an abstract thing, a conceptual thing. And we might have a particular ticket with that fare that's valid from the 1st of May to the end of May. And that's when the sort of the duration in a sort of a period, like a month, becomes a date range. Right, so that's really when you get into having a ticket. In the SDCI Plus, tickets are represented by these things called BE records. Season tickets are represented by BMs because they have a slightly different structure. But these two character codes that I'm talking about are essentially the first 2 characters of the record. So every new line, every record in the file has one of these types, and they're just 2 characters. Supplements are an additional rail product that is sold with the ticket. And the sort of most common one you'll see is just a reservation. So there's no fee for that, usually. And it's just there's a reservation supplement that goes along with the ticket. But other things include meals, car parking vouchers, all sorts of things. Bicycle storage, I think, is occasionally a supplement. Now these things are also represented as BE records in the SDCI Plus, and that's largely because structurally they're kind of similar, but also coming back to that model of the ticket office, their supplements are printed on the sort of orange CCST stock, right? So it's kind of like they're a ticket. But unfortunately there are differences between the sort of data in a supplement and a ticket, and so sometimes you have to sort of mangle the supplement into a BE record by taking information from the ticket with it's associated to. An example of that would be a supplement I don't think has an origin and a destination or a route code, so typically you just take the one from the ticket and cram it into the record. Right, sundries are everything else, right? So card fees, delivery fees, teddy bears, chocolates, whatever you want to sell that's not really a rail product, that's a sundry. Now, as we will see as we go through this, sundries are used as sort of a get out of jail free card for anything that doesn't fit the model, or is not quite, it just sort of doesn't fit the system very well. Then people will just make a sundry for it. They're represented as BP records. So tickets are BE and sundries are BP. In terms of payment, there are many types of payment, more than I thought possible, but the main ones you'll see are cash, card, warrants, automated warrants, and those sorts of things. Warrants and automated warrants is a bit of a tricky one, but a warrant used to be something that you would sort of be given down the station. Let's say your train was late or something, they might give you some money back in the form of a warrant that you can use as a discount code. But they're also used for pay on accounts. Automated warrants seem to be more popular now. People tend to be trying to keep the sort of warrants for different things. So yeah, they're just slightly different. All right, and coming back to the transactions that are actually in the SDCI Plus file. There are a few rules around these. So SDCI Plus is based on a zero-sum accounting system. And what that means is that every transaction inside the SDCI Plus file should be balanced. It should equal 0. If we sell £100 worth of tickets, some supplements and sundries, then there must be exactly £100 worth of payment records in the same transaction to offset that. So on sort of an individual basis, every transaction must balance, and therefore the whole shift will balance. Now the way that works is that each record in a transaction is either considered credit or debit. So that's the products and the payments. Now some records are kind of by nature a credit or a debit. So things like tickets are by nature, one thing. And other things have a credit debit marker that can be set inside the record. So payments and sundries. If you have a payment, you might be taking money or you might be giving a refund. So there's a credit debit marker, and the same thing with sundries. You might be sort of giving or taking, essentially. And what that means is that the number of credits we give must be the same as the number of debits that we take. Okay, so I'll run through some examples just so that we can see that kind of interaction in play a little bit here. So this is a kind of mock version of a shift with one order that has a card payment and one order that has a warrant payment. So at the top I mentioned there is a DB shift header with the totals, then there's your version record. Now we have our first transaction here. So it's got the transaction header, which is a CF record. Then that's followed by a ticket that we're crediting. So where the sort of person is getting a ticket, they're getting a reservation. Now, funnily enough, they're getting a delivery fee. So this is a sundry, this is a BP. They're getting a card fee, which is, again, this is not something you would perhaps consider from a customer's perspective to be getting anything, but it is effectively something that we're selling you. So if you're placing an order and we're charging you for a delivery fee, you're getting a delivery, And then we have a card payment here that we're debiting, that we're taking.
So the next transaction, we have a BE.
You're breaking up. I can't hear you, but I don't, that's just me.
Ah, dear.
That's you.
Oh, okay. It's okay for everybody else?
We can hear you.
Brilliant. I will keep going.
No, the quality of connection is perfect for me. So. Yeah.
Okay.
What about the others?
So the next transaction, very, very similar, has a BE ticket, has a BE supplement, a couple of sundries, and then it has a CW card payment, which is a credit, and then it has a shift footer. Okay, so there's a couple of weird things in there which you may or may not have picked up on. So the first thing,
Can I have a question?
yes, go for it.
Why there is no debit in the second transaction?
Yes, so that is one of the weird things that you, if you are paying attention, you will have noticed here. So the credit debit marker is the opposite way around for product records and payment records, okay? So product records are written from the perspective of the customer. And that means that when we're talking about tickets, you know, we credit the customer a ticket. They're getting that. And so when we come to payment records, though, they're written from the perspective of the system. So the system is credited a payment. So you'll see that they're both, a ticket is a credit and a card payment is a credit. However, you may have also spotted that in this example, the card payment is not a C1 record. So a few slides earlier, I showed the payment types, and they all begin with C, and card payment is C1. However, the C1 payment record is only used when Lennon is doing the settlement. So settlement is the financial actual movement of the money. So when you do sort of payment systems and things like that, they break down into authorization and settlement. Essentially, Lennon used to do settlement, but not anymore. And so as BP or sundries are get out of jail card free, we use one of those to represent our card payment. That leads to the rather bizarre situation that as BP records are written from the perspective of the customer, they are debit. So we have one payment which is a debit, and we have another which is a credit, when the reality is the money is all going the same direction to us or to the TIS. It's just the perspective of the BP records, and the C records is the other way around, so the credit and debit is it's opposite, right? So that's a slight quirk of the system, but you know, nothing too bad. Yeah, but that's basically it here. So we can just quickly skim through it again. You know, we're giving a ticket, we're giving a supplement, we're giving some card fees because we're very generous like that, and then we take a BP payment, and then the other one is the same thing, but everything is listed as credit. However, in the second transaction, as it's a CW record, effectively the value of the CW record is offset by the B records, and so everything equals 0, and life is good. Okay, so that's one scenario. That's sort of basics. The next scenario is a TOD order. Now this order has 2 passengers doing 2 trips, so we'll say 2 singles. And that results in 4 tickets. If you imagine each passenger gets 2 tickets, 1 for out and 1 for back. And yeah, in this example, we again have our CF transaction up here, and then we have our sort of ticket record here, which is in this case it's a BP. We have another ticket record, then we have all of our usual sundries, and the shift footer. Okay, and again, sort of like, wait, what? Because in TOD, the first thing to note is that our ticket records are not BE records, they're sundries, they're BP records, right? And that is essentially because the ticket is not actually created. When you do a TOD order, the customer pays, and then you put that order into a system called LSM, live sales management. And when they go to the station, they go to a ticket vending machine, and then they collect their tickets. So in the eyes of the rail world, the ticket has not actually been created. So we create a BP sundry for this thing that we've done, and then when the customer goes to the station, the TVM will essentially refund that sundry, and in the same breath it will issue some tickets with real BE records. It's something called indirect fulfillment. Now, that being said, the other thing to note is that we have 4 tickets, and possibly, I didn't mention reservations, but possibly some reservation supplements as well, and yet we only have 2 sundries. And that is because for TOD transactions, they get grouped together by fare, and this dates back quite far, but essentially generating the CTR records that go into LSM used to cost money per one you generated or per transaction reference you used. And so people tried to group together situations where you had many passengers all using the same fare. And in our example, we have 2 passengers using the same fare, and there's 2 fares, so we have 2 tickets. If there were 5 passengers with 2 fares, you would still have 2 sundry records. The other thing to note is the supplement records also get rolled up into these sort of individual BPs. So that can be a little bit strange at first. The other thing to note is that the total price of that BP, the sundry you create, is the price of all the tickets and all the supplements. So given that most supplements are reservations and don't have a cost, it's easy to forget to add the cost of the supplement in there, but it's all got to go into that single BP record. So I think that's basically it. Okay, so yeah, that's it for the TOD. I'll just sort of recap that. This sundry record here is sort of 2 passengers in one direction. The next one is 2 passengers in the other direction. So it's grouped by the fare. Cool. Barcoded tickets. And again, this is another type of transaction you might see. This one's relatively new. But if in this example we have one order with 2 barcoded tickets, and so here we have, rather than a CF transaction header, we have a new one called a CG transaction. Inside of that CG transaction we have a BE ticket, so it's not a supplement, it's a normal ticket record, followed by, let's say, the reservation supplement, also a BE. As the transaction has to balance, you need to have the payment. Then again, your second ticket goes inside of its own transaction header. And then finally, you have a third CF transaction this time that has the card fee and card payment record for that card fee. Again, a bit of a, what the hell, because typically one order will equate to one CF transaction. That's kind of how the world works. Somebody places an order, it's got a bunch of tickets in it, so we generate a transaction for that. However, for whatever reason, when there are barcodes involved, they all have their own CG transaction. So every ticket has its own CG transaction. Essentially, that is to incorporate some new fields that are relevant to barcodes inside the SDCI Plus. It could have been done differently, but it wasn't. It does mean that the payments are now split over each of the transactions. So whereas we actually only have one payment, the customer's only made one physical payment, we have to split that payment into 3 different payment records, which again is a bit bizarre. And it gets more complicated when you factor in that you can actually have multiple payment records per transaction. So you might pay some part on warrant and some parts with a card, and then you have to work out how you're going to divide that across multiple transactions, which is lots of fun.
Can I ask something?
Sure.
What happens when you have a ticket, like multi-passenger ticket? You have like 3 passengers on, or let's say 2 passengers on a shared ticket. Is it like one passenger is actually one ticket for SDCI Plus, or it's?
Yeah, it's actually quite a complicated question, and I mentioned multi-passenger tickets slightly later on, but essentially tickets are by nature multi-passenger. Each BE record and a lot of the source data in the fares feed supports multiple passengers. It just so happens that the most common type of tickets is sort of, you're normally dealing with one person on a ticket, but the system fully supports multiple passengers on a ticket, and traditionally it is considered one record, because you might have 2 people with one price, or one fare I should say, and that's what makes it a multi-passenger ticket. So what would typically happen is you print one ticket, it says it's got 2 passengers on it, you have one SDCI Plus BE record, and that says it's got 2 tickets. Now, in recent years there's been issues at the gates, because it's difficult to get 2 people through a gate with one ticket. So the TOCs like people to issue 2 tickets. And that actually means that there are multiple ways you can write the SDCI Plus for multi-passenger tickets. You can write them as a single ticket record, or you can write them as a ticket record for each ticket, because if you print multiple coupons, then you could argue, well, I'll write multiple BE records. The other thing to bear in mind is it's a similar situation to carnets, which I might touch on later, is that sometimes the lead ticket gets 100% of the price and the subsequent tickets get a 0 price, and other times it's divided. It's really, that's an area where different TISs do different things. So anyway, but yeah.
Actually, with this new shared tickets, we are supposed to do one BE record for the ticket, and for each reservation, which is a supplement, another BE record. So the transactions would be one BE ticket and, for example, 2 BE supplement records.
Yep.
Okay.
Yeah, I mean that's what I consider the traditional correct way of doing it. In my view, the system was modeled to have multiple passenger tickets. The TOCs keep using them, and I think it's right to use SDCI Plus and whatnot in the way it was designed, but it's really a matter of opinion. But back to the barcode tickets. So this final transaction here, this CF transaction, basically anything else you've retailed needs a home. So if you've got an order with 2 barcode tickets, then you have 2 CG transactions for those barcode tickets. You need an additional CF transaction for the remaining delivery fees, card fees, teddy bears, chocolates, whatever else it is. And yeah, so that's where that goes. Yes, cool. So we've covered orders, TOD, barcoded tickets. Now we're going to come to a different type of transaction. So all of those previous transactions are issuing. Now we'll talk about non-issuing. Essentially, non-issuing was created to deal with printing failures. So again, back at the station, when people used to print things out, occasionally the printer would jam and it would all go a bit wrong. And so non-issues are a mechanism to roll back the transaction that's just happened. In this example, we're looking at a fairly simple one order with 1 ticket and a reservation. So the issue transaction is this first CF record here with the BE and the supplement for that, then a card payment. But it goes wrong, and so there is a non-issue created, which is a BF record and a BR record. So not every record type has a non-issue version, but these ones do. So when you non-issue a BE ticket, you write a BF record. Structurally, they're exactly the same, but they're just the inverse. So previously, when we are issuing a ticket, we're crediting the customer with a ticket, and with a BF record, we're effectively taking that ticket back off them. We're saying, sorry customer, that went a bit wrong, so we're taking it back, it's a debit. And that's really all it is just the same information inverted. And when I say the same information, I kind of mean that quite literally, because for records like BPs that have a credit debit marker, you would expect that you would invert the credit debit marker, because it's the opposite way around now, but you don't. So where you have a card payment here, the credit debit marker will be set to D for debit. However, when you're adding everything up to sort of make sure the transaction balances, it counts towards the credit columns. Again, it's slightly unusual, but it's just down to how it all works out. Oops. Where am I? Oops. Cool. Refunds is another type of transaction. They are slightly different in that everything we've looked at so far, one transaction, relates to an order. In this one, it's quite important to remember that one order may have many refunds. So there's no, the refund itself is the parent of these SDCI Plus transactions. And it's a pretty basic construct. We have another CF transaction header here. We have a BS record to say we've refunded the ticket. That has an amount, because you can do partial refunds of tickets and things like that. You might also refund a supplement. You can, if you refund a sundry, there is no refund record for them. It's just another sundry, but with the credit debit marker the other way around, I believe. Typically, when you're doing a refund, you will charge an admin fee. So let's say we're giving back £100 worth of tickets. We will charge a £10 admin fee. Therefore, we will give you £90 credit back to your card. So yeah, like I said, reasonably straightforward on that one. Uncollected TOD refunds are a variation of that. Obviously, it's another type of refunds, but previously I mentioned that TOD transactions are written as sundries because in the sort of eyes of RDG and the TOCs, they are not tickets yet. Whilst they're sitting there in LSM, the customer has not collected them, they're not yet tickets. So what we do when we're going to refund an order like that is we actually do a virtual issue, and that's the same process that the TVM machine does when the customer comes to collect the ticket. We say, okay, those sundries that the retailer sold you, or we sold you in that case, we're going to reverse those. We'll write some sort of, non-issue reversal thing, and then we will do a virtual issue transaction. So this first transaction here is the reversal. The next transaction is an issue. Now, one thing to note about this issue is that there is a sundry to make it balance, because each transaction needs to balance individually. There is sort of a sundry that goes along with this, but then after they're issued, you can then refund the ticket in the normal manner. So effectively all we're doing is pretending we're a TVM, we're refunding the sundries, we're issuing new tickets, and then we're refunding those tickets immediately. In my opinion, it probably should have been done as a single transaction. RSP say it's got to be 3 separate transactions. Yeah, enough examples already, right? That's that's plenty more. There are a lot more things, but those are the kind of high level ones. So you can already kind of see that there are multiple layers or dimensions of complexity there. There are 3 main actions that that can occur. You can be issuing things, you can be refunding things, or you can be non-issuing things. Those are the 3 primary types. So it's sort of like 3 entry points, and then on top of that, along each one of these streams, you might find that the behavior changes again based on the fulfillment method. So in all of these examples, TOD is different. Barcodes are different, and then the third and sort of last layer is the individual product types. So your question about multi-passenger tickets, yes, they can be different. Carnets are very, very similar to multi-passenger tickets in SDCI Plus terms, and discounts. The way you implement discounts is fairly straightforward for percentage discounts, but flat rate discounts involve additional sundries and things like that. So it is, before you categorize it all like this into a hierarchy, it is actually quite a mess, because you can have, what happens when you sort of have a multi-passenger TOD ticket that you're refunding and whatever, and you just get different combinations of complexity. But it's better when you can all lay it out like that. So I think I mentioned earlier that SDCI Plus plays quite a key role in the sort of TIS as a whole, in the architecture of that and in the process. Now, every product in a TIS has is modeled in a finite state machine. So there's like a product state transitions that they go through. And you'll see this in a lot of the RSP documentation and other places. Essentially, when you create a product, it's held, and then you might pay for it, and it moves into the sold state, and then you issue it, and it becomes ready to fulfill, and then you fulfill it, and it's fulfilled. The part that SDCI Plus is concerned is purely issuing. Now, issuing is basically the process of assigning those transaction numbers, and the reason that needs to be done before the fulfillment is because, particularly in CCST tickets and barcoded tickets and things like that, the transaction numbers will go onto the face of the ticket. So it's kind of like not quite a chicken and egg problem, but you need to do the issue before you do the fulfillment. In fact, as almost all failure scenarios occur in fulfillment, life would theoretically be much easier if you could reverse that process, just fulfill a bunch of stuff, look at what you did successfully, and then write the SDCI plus. But because the transaction numbers are needed to go on the face of the tickets, you can't do it, and it's got to be, you pay, you issue, and then you fulfill. In terms of the architecture, this actually is modeled quite nicely and breaks down into sort of services quite neatly. In theory, you might have an order service or some sort of a journey planner that helps you create the products in a held state. Then you have a payment service which does this pay function and moves things into the sold state. And then you have an SDCI Plus service that does the issue and moves things into the ready to fulfill state. And then you have one of many fulfillment mechanisms or services that move it to the fulfilled state. So it is actually quite neat and tidy. In generally, I quite like the SDCI Plus system as it is discrete. It doesn't venture outside of its box too often. That sort of mapping of transaction numbers onto products is really the only part where it sort of has an impact on the rest of the system. And unfortunately, there is a bit of a sort of impedance mismatch there between the two domains. So let's take TOD as an example. In our order service, we may say that we've sold 5 tickets. The order will contain 5 tickets. We've got 5 passengers going from Tunbridge to High Brooms, wherever. And so our order has 5 tickets in it. Now, when it gets issued by the SDCI Plus, that doesn't map very well back to the original model, because SDCI Plus, if you remember, for a TOD transaction, will just issue one sundry, right? So, the order may have sundries in it, but not these ones. And so you have to then take the transaction number from that one sundry and map it onto 5 tickets and then ship it off. And what's worse is that your fulfillment mechanism will then try to have to reconcile those differences. It is discrete, it is self-contained. However, that small bit of interaction it does have doesn't always match up very well. There are some implementation tricks. So one of the main things that will go wrong in SDCI Plus is that the transactions will not be in sequence. There'll be a gap or something else has gone wrong. And when we first implemented this, we used like SQL style, Postgres style sequences that roll over. So they're 5 digits, right? So when it gets to 99,999, it rolls over to 0. So that can be quite tricky to deal with when you roll over your transaction in the middle, or you roll over your transaction numbers in the middle of a transaction in the middle of a shift, because you try to bring it back at the end of the day and write it to a file, and the ordering is all messed up. So your zeros go to the top, and then it's all wrong. So one of the things you can do on that is to just use ints with sort of the usual 64-bit upper boundary, and only take the last 5 digits of that integer, and then that will naturally roll over. So when it gets to 99,999, it goes to 100,000 after that, but you're only taking the last 5 digits, so it looks like 0. But you have the correct numbering, because you can still order. So that's quite handy. The other thing to bear in mind is that assigning transaction numbers must be done inside of a transaction, and when I say that, I mean the traditional database sense of a transaction, It must be atomic, and there can be no race conditions. So a transaction number can only be used once. If you have two individual processes that both read from the database for the latest, what's the next transaction number, they both take the same one, they both use it on a different ticket, you'll have problems when you try to build your SDCI Plus at the end of the day. That's relatively easy to solve with relational databases. If you want to use fancy technology like NoSQL or whatever, you're going to have other problems, particularly in a distributed system. The shift totals I mentioned are also a thing that will go wrong occasionally. If you're not adding things up correctly, your shift totals can go slightly wrong. What we typically do is to maintain a running tally. So every time we sort of sell a product, we update the shift header and footer or whatnot. And then at the end of the day, we sort of recount everything to make sure we didn't get it wrong over the course of the day. But that's sort of optional. Yeah, so that's it really, as a very high level introduction to SDCI Plus, what it is, why it is, and what it looks like. It's not really very complicated, but it is mission critical, and I think that's one of the reasons why it has a sort of mysterious aura, is because if you touch it or you break something to do with the order that it's doing things, then it goes wrong and people get a little bit upset. Cool. So yeah, oops. Yeah, thank you. I think that's it. Are there questions? Are there any other aspects to it that I didn't?
Sorry, I'm not sure. Can you hear me, Linus?
Yeah.
I'm not sure if this is a question to you, but it's about the non-issue state. Because when I go to our test back office, I can see that some tickets has the status, and I would like to know how we can, create it technically. When I test, how I can get the status non-issue.
So non-issues. Typically, like I said, they represent a fulfillment failure. Now, as systems have evolved and, we've moved beyond the train station model to a web TIS living in the cloud, retailing tickets, people have started using non-issues for other things. We don't, but other people do use non-issues as a form of refund. So if you haven't issued a ticket and you want to refund somebody, I believe you can do an issue and a non-issue immediately, and then there's no admin fee involved in that, so it's quite a nice thing to do. So in terms of our system, how can you create those? You typically, the only way you can do it deliberately is loading up the CCST printing app and then selecting the void from that once you've printed something. So basically, the operator of the CCST printing app can say, this ticket didn't print correctly, we need to non-issue it, and our system actually enforces another thing, which is a reissue. So when you non-issue something, it will immediately reissue. So if you print something, you say, that doesn't look right, I'm going to void it, I'm going to non-issue it. Then another order with a new order ID will appear in our system so that you can hopefully retry printing.
Okay. No, I just wonder because okay, we must try to play with our back office.
Well, it's not in the back office, it's in the CCST printing app. Yeah.
You can't do it through your back office though, because that's how you and Alice do it if they need to do it for a customer.
No, you can't.
You can.
No, you can't. We're being recorded, Harriet.
Oh.
Yeah. So yeah, that's a good point. I think there is something in there to just manually trigger a non-issue. I didn't realize it still worked actually. So yeah, I'd quite like to know how, because when I go to the non-issue page, there's no orders I can non-issue. But
Yeah, it doesn't work from that page. That's broken.
Okay.
You have to do it within the URL.
Cool. Yeah. But you know, I don't think there's anything too wrong with it. Are there any other aspects? The only thing I was thinking is those are the high level concepts behind it that I think are relevant, but are there any, you know, other things that people want to know about it? I didn't talk about how the files actually get to Lenin. You know, there's a VPN, there's SFTP, it's pretty straightforward. Yeah, you know, there are cron jobs that in terms of a web test, we don't literally have people coming in and opening their shift and retailing tickets in the morning, so we always have a shift open. We have a cron job that runs at midnight. It just closes the previous shift and then opens the next one, and again that's done in a single transaction so that it can never fail, or if it fails it rolls back rather. And yeah, so then later on the SDCI plus file is built and sent. I realised I said one thing in there which I'm not entirely sure is true actually. I said there is no refund record for a sundry, and I think that may be incorrect. I'll need to go and check. The refund record for a sundry may be a BR, which is the non-issue for a sundry, but that will need checking.
Is there anything different for seasons? Is it exactly the same because it's just a ticket or for there?
Yeah, seasons are pretty simple. They are a BM record. They have different fields, different data. But that's it, really. Yeah.
Okay.
Okay.
Excellent. All right. I'll stop recording now.